Last night's homework starts off like this. Just like if it was algebra, what would you do first? Jesse? Good. Let's just treat it exactly like it's algebra to start. And so I'm going to distribute this cosine through, which will give us the cosine times secant, and then cosine times cosine is cosine squared. So these will behave very much like variables for us, but now instead of just one letter, it's a word basically. So a lot of this algebra is going to be the same as if we're doing all variables, but now it's a little more complicated because there's words involved. So the next step I would encourage you to do is start to think about things in terms of sine and cosine. So secant can be written as 1 over cosine. And so that helps us because cosine times 1 over cosine is just 1. And so we'll end up with 1 minus cosine squared. And do we have anything in our toolbox that looks exactly like that? Not exactly like that. So here's where the manipulation piece comes in. Hopefully one of the rules you guys remember, not necessarily have to memorize, but I think this is one of those ones that's kind of important, is the idea that any spot on our unit circle is the point cosine comma sine. And so if we were to build a triangle off of that, our x value is cosine, and our y value is sine, and the radius is 1. So with right triangle trig, Pythagorean theorem tells us that a squared plus b squared will equal c squared. That's one of those things that's been drilled through us for forever. So we can say that the base, a squared, which will be cosine, plus the height, which is our sine squared, is going to equal our radius squared, or the hypotenuse squared, which is 1. So cosine squared plus sine squared equals 1. Hopefully that's one of those things we'll start to be familiar with. Okay? That doesn't look exactly like what we want, but it does have all the pieces involved. There's sine squared, there's cosine squared, there's a 1. Can we manipulate this identity? Well, if I have 1 and I want to subtract cosine squared from it, let's just do that and see what happens. So as we subtract cosine squared from both sides, we see that sine squared will equal 1 minus cosine squared. And now we have a direct substitution that we can plug in. So now this piece can get plugged in for that, and we see that we just have sine squared equals sine squared. Okay, so a lot of this is algebra comboed with manipulating stuff and kind of like a puzzle so that things will match up. Yes, Blake.
So how do you know when you're ready to replace it? Is the 1 minus cosine squared one of the things in the toolbox?
It's really close to one of the things in the toolbox, because the thing in the toolbox is this. We just had to manipulate that toolbox piece so that we could substitute it. So if we were to look at another example from last night, like 23, this one, similar approach, we'll start by distributing. So we end up with tangent times cosecant and tangent times cotangent. And ultimately what we want this to look like is the secant theta plus 1. So we'll see kind of what starts to happen. If we go into our sine and cosines, we see that tangent can be written as sine over cosine. Cosecant can be written as 1 over sine. Tangent times cotangent is just 1, because we can think about cotangent as 1 over tangent if we want, or you could switch it into sine and cosine if you want. But either way, no matter how we adjust these, this is going to turn into 1. Okay? And then sine on top, sine on bottom, we're left with just 1 over cosine. And 1 over cosine is secant. So after we have some of this simplification here where the tans would cancel, we would end up seeing that secant plus 1 equals our secant plus 1. So sometimes just going to sine and cosine, everything starts to get simple. Sometimes we need to do some of the bigger toolbox pieces. Yes, ma'am.
So like on 19 where you got to the point where it was 1 minus cosine squared
Correct.
equals sine squared, do you have to do what you did and show the work that you can prove 1 minus
No, because
cosine squared?
ultimately, you could say sine
So
squared
you
equals
can
sine
jump
squared at
from
that point.
to- okay.
Yeah. You just have to have the ability to know that's possible. And like if something didn't match up, like let's say you had like 1 plus cosine squared there and you just jump to it, there'd be some weird little thing in there. There'd be some other small error. But yeah, as long as it actually lines up and matches, so maybe for your own sake, kind of double check to make sure it actually matches. But yeah, you'll start to recognize these things. So like as we go into some of the things tonight, this one is number 28, so it's similar to like 27 and 29, I believe. We can start to see things that are similar on top and bottom, so we can find common terms. What's common on top here? There's the cosine in both these terms. So if I were to factor those out, we can have a cosine theta times the quantity that's left would be sine plus, and if I pull cosine out of cosine, what's left? 1. Gotta make sure you leave that 1 as a placeholder, because you want to remember if I'm trying to factor this back or distribute this back in, I should get to the same spot. Okay? And then on the bottom, what's the same? So what's a common term? We have sine in both. So if I pull out sine, in this case, I'm left with 1 plus sine. Those look a whole lot alike, don't they? And with addition, the order does not matter. So we can say sine plus 1 is the same as 1 plus sine. Those can cancel top and bottom. And then cosine over sine is cotangent. So some of these you're going to be able to factor out, and it makes life a whole lot easier. Things just start to disappear. And then I think the most complicated we're going to get tonight is going to be stuff like number 40. Number 40 is going to require us with common denominators. So again, just basic algebra stuff. How do we add and subtract fractions? We must have a common denominator. What would my common denominator be in this situation? Secant. Good. So to make this have a denominator of secant, we can multiply it by secant over secant. Okay. Why am I allowed to do that? Because it's 1. Okay. Multiplying by 1 doesn't change anything. So now, when we start to do that piece, we'll see that we'll have a secant squared on top. We'll have secant on bottom minus tangent secant. Okay, with a common denominator, we can put that over the same thing. So now we have secant squared minus tangent squared all over our secant. And here's where I'm going to start to be like, okay, now what can I do? Well, I know that cosine is the same as 1 over secant. So what do you think I'm going to hope like crazy secant squared minus tangent squared is? 1. Because I want 1 over secant, right? So if I go and look in my toolbox, is there anything that involves secant squared, tangent squared, and 1? And we would see that, yeah, there's something where it's 1 plus tangent squared equals secant squared. Okay, so again, not the exact substitution that we're looking for, but it's got all the pieces, so let's see if we can manipulate this one. So in this case, we want secant minus tangent. So if I subtract tan from both sides, we will see that we're left with 1 equals secant squared minus tangent squared. Okay? And that's what we're looking for. So now we have that direct substitution. So this is 1, which is what we're hoping for. So we end up with 1 over secant. And 1 over secant is cosine. So again, the big piece is you're going to try to use basic algebra stuff that we're used to doing, but just know it's with words now instead of numbers, okay? And words instead of just variables. Similar approaches. Then try to use your toolbox to help us do some manipulation and some substitution. Things will simplify and kind of disappear.